Hello again. Now we look at inverse functions. The idea is whenever we have operations of this kind of composition, I'm looking for things that actually represent identity function and something that represents inverse. So let's have a look at this idea. What I want to do is this. I want, and this should be fx equals x. I want the idea of identity. In other words, a function I compose with that makes no difference, makes no change. So x equals x is the identity function because it doesn't change it. So if I compose f with g and g with f, I just get gx back, because all this does is, this says leave it alone. Don't do anything at all to it. So if I do f of g, it says it's equal to x. So I get gx back. And g of fx just gives me x back. I get g of x out of it. So fx equals x is the identity function. Then I think of inverses. I want a function that goes this way and one that takes me back again to where I start off with. So I call this f inverse as f to the minus 1x. It doesn't mean a power here. Here it means the inverse function. So this is the domain of f. It takes me to the range of f. The inverse function takes me backwards. So this is the domain of the inverse function, and it takes me back that way. So domain of f takes me to range of f, but if I go backwards, this is domain of f inverse, it takes me back to range of f. So you can see the domain of f is equal to the range of f inverse, and the range of f is equal to the domain of f inverse. So if I've got fa equals b, I want the inverse so that f minus 1 of b takes me back to a. So f takes me from a to b, and f inverse takes me backwards. A to b for f, inverse takes me backwards. Let's have a look at fx equals x squared example. The domains are all the real numbers, and the range is all the non-negative numbers. If fx equals 0, I get x equals 0. No problems at all. F is 0 is equal to 0. But if fx equals 1, then what value do I give for x? Because if x equals 1 means x squared equals 1. Gives me as x as plus or minus 1. And this is a problem because I want to go back to only one value of x, not two values of x. So we restrict the domain of f so that f is a one-to-one function. In other words, if I take a look at the same function, fx equals x squared, at the moment it looks like this. I get the value for 1 and the value for negative 1 to be the same. If I restrict my domain here, so that I change this to the domain of f is x in R such that x is bigger than or equal to 0, then all I have is this part left. And I wipe off this part here. Now this is a one-to-one function. For every value of x, I get one value of y, and a value of y corresponds to only one value of x. So I've changed my function from something that was not one-to-one. In other words, I had two values of x giving me the same value of y, to something that only gives me one value. So in this case, I can think of this as, if I've got fx equals x squared, so f at 1 equals 1, and so the inverse at 1 will give me 1. F at 2 equals 4, so f inverse at 4 will give me 2. And it's clear in this case that f inverse of x is the square root function. Horizontal line test, similar to vertical line test. If I only have one value of y for each value of x, remember the idea was for each value of x I get one value of y, that is the vertical line test. Fix the value of x, I get only one value of y. To reverse it, for every value of y, I want only one value of x, then the horizontal line test gives me that to me. So First of all, I require a function, which means the vertical line test must hold. And now I will require the function to be 1-to-1, so the horizontal line test must hold. In that case, I must have only one intersection, at most one intersection of the graph of the function with a horizontal line. So this function here, the first one, is 1-to-1, and this one isn't 1-to-1. It's a function, vertical line test holds, but it's not a 1-to-1 function. So inverses exist only for 1-to-1 functions. So the way it works is there's also that every 1-to-1 function has an inverse. Inverse is unique, which is also good. It's also 1-to-1. So you can see that F has its inverse F inverse, and F inverse has its inverse F, of course. And if I compose a function with its inverse in either order, I get the identity function here. So F equals F, we know that fx equals x is the identity function. So whenever I compose f with its inverse, I get this. So a function that's equal to simply x is the identity function here. And all of these, the f and inverse must be defined over the appropriate domains and ranges. So here's an example. We've got a function here given to us with values there, and I want to work out f of g at -2. So let's have a look at this. -2, what's g of -2? There's -2, g is equal to 2. This is the same as saying this is f at 2. So I look at the table for 2 and I find f and I get -2 out of this. G of f at -2. What's f at -2? -2, f at 0. Go to 0 and find the value of g, I get 1. F inverse at 1. So now I want the value of f to be equal to 1. So fx equals 1. So I find the value which corresponds to 1 here, and I find that the f inverse is -1. Yeah, f inverse of 1 is equal to x, means fx equals 1. The value of x is what I want here, that's the inverse at 1. And I find the value that I get 1 from is -1. G of f inverse at 0. F inverse at 0. F at 0. F is 0 here, f inverse is -2. Again, I want f inverse at 0. So I look at the value of f as being 0. Inverse goes backwards. I get -2 out of this. And g at -2 here is 2. G inverse of f inverse at 1. So f inverse at 1. There is 1. F inverse is -1. Now I get -1 for g, and I look at the inverse, I get 1 out of it. Have a careful look at these because these are a little tricky. Next one says f of g inverse at -1. This is tricky. F of g inverse at 1. So I want f of g inverse at 1. If I put this as x, that means f of g at x is equal to 1. So that means, first of all, f at some point gx is equal to 1. So on the value of x where fx is equal to 1, fx is equal to 1 at 1. So f at some point is equal to 1. F is equal to 1 at -1. That means that gx must be -1. and gx is -1 at 1. So what I found here is f of g inverse at 1 is equal to 1. Tricky table, tricky to work with, but take care, you'll be okay. Have a good look at that one. Finding inverse functions in the next lecture. Bye-bye.